Hi everyone. In this presentation I'll show you how to test for moderated mediation using AMOS, with the tests being based on Andrew Hayes process model number 7. Files related to this presentation, including the PowerPoint, the dataset, and so forth, can be downloaded from the links underneath the video description, so be sure to download them to follow along. If you find the video and supporting material helpful, please take time to like the video and share it with others. So our example is based on a data analysis from Muller et al. On mediated moderation and moderated mediation. Although the data used here was associated with their presentation on mediated moderation, we're also going to use it for the current presentation on moderated mediation. So within this particular model, Model 7, within Hayes process framework, we have essentially variable x predicting variable y, and that effect of x on y is flowing through a mediating variable, which we'll designate as m. So with the data that we're going to be working from, our x variable is prime, our y variable is behavior, and our mediating variable is expectations. So conventionally, within our mediational triangle, we would designate this path as path A, this path as path B, and then this path right here would be path C prime. Now you'll notice that we have this variable right here sort of sticking out, and this is social value orientation within our example. And this is our moderating variable, which we'll designate as W. And so the basic idea within this system is that the effect of x on the mediator variable is being moderated by social value orientation. In other words, the slope for that relationship varies across levels of our moderator variable W. So what we're going to be doing in this example is testing a couple of things. We're going to test first off the simple slopes for this path right here. So in other words, we're going to test each of the individual slopes for the effect of prime on the effect of prime on expectations at different levels of the moderator variable. So we're going to be testing simple slopes. And then we're also going to be testing the conditional indirect effect of prime on behavior. So the conditional indirect effect is computed by taking essentially the simple slope associated with path A and multiplying it by path B. So that's how we're going to compute those. And we're going to test those for statistical significance. So the model that I've just gone over is basically laid out as a conceptual model. So we can't actually run the statistical analysis directly from this model. We have to actually specify a statistical model using our AMOS program. So on the right we have our statistical model, and you'll notice that we have, first off, the mediational triangle is pretty much laid out the same way that we always do, which is that we have our x variable right here, we have our y variable over here, and then we have our mediator right in the center of this. So you'll notice that we have a path A right here and a path B right here. And within the standard mediation framework, the indirect effect of prime on behavior would be computed as a product of paths A and B. Then this path right here, from prime to behavior, this is called the direct effect, and conventionally it's referred to using a C prime. So that's just kind of the standard approach. Now in this particular framework, what we're having to do is add social value orientation and the interaction between prime and social value orientation as additional predictors of the expectations variable, which is our mediating variable. So what I basically had to do was to go into SPSS and take these original two variables right here and multiply them to obtain this variable right here. So this variable actually appears in the data set. So we have to include that in order to run our model. So next up, the other thing to note too is that we have all three of these variables. These are our exogenous variables within the model, and all three are correlated with each other. Additionally, where you have A, B, and then I've also have a C right here, these you have to assign labels to these paths. So basically when you're testing for conditional indirect effects, what you're going to need to do is to assign certain labels to some of the paths within your model. So basically I just labeled this one path A, this one path B right here from the mediator to our outcome variable. And I went ahead and labeled this one path C. Although conventionally, again, the direct effect right here is conventionally C prime. If you're reading the Barron and Kinney article or whatever, you'd see that. But instead of using that, I'm not really going with that kind of approach. I'm just basically labeling this path right here as yet another path, and I'm just calling it path C. Additionally, you're going to need to obtain the mean and standard deviation for your moderator variable. So this is just descriptive statistics that I generated using SPSS. You'll notice the mean is essentially 0. That's because the authors had actually already mean-centered that particular variable. This is the standard deviation for that variable. But basically, if you hadn't mean-centered the variable, then you would definitely need the mean when running your analysis, in addition to the standard deviation there. Now, with the mean and standard deviation in hand, then you can go under the define new estimands in AMOS and basically type in some syntax in order to run your model. I'll be honest, I'm going to have a link to this file right here, both as a notepad and also as an AMOS file underneath the video description, so you can actually download it and probably just plug in a few changes and run your analysis, just so long as you use the same labeling that I'm using. So, but just to kind of highlight what's going on in this, first off, I've kind of set this up where we are testing the simple slopes for X on the mediator at different levels of the moderator W, and I'm just using the standard pick-a-point approach. And which the standard pick-a-point approach is just basically designating 3 points along the scale for the moderator in order to test to generate and test simple slopes. So basically, a low value would be 1 standard deviation below the mean for the moderator. A medium value would be at the mean, and a high value would be plus 1 standard deviations from the mean. So we're basically going to be generating simple slopes for this first part right here at essentially 1 standard deviation below the mean on social value orientation, at the mean on social value orientation, and then above the mean, 1 standard deviation above the mean on social value orientation. Then down below, these are basically, this is kind of the syntax for generating the conditional indirect effects of our prime variable on our outcome variable behavior at different levels of the moderator W. And again, we're going to use those same 3 points for the moderator variable. So starting off, though, with path A and generating those simple slopes, what I'm doing is essentially typing in, giving a name to a new parameter, which is called low SS, and that's just basically the simple slope at low W, the low value on the moderator W. And so this is an arbitrary naming. That's just how I chose to name that particular parameter. Then I say equals, and then I've got A plus C. So A is path A, basically running from our X variable prime to our mediating variable, which is expectation. So it's basically path A right there. And remember that within our model, we essentially had our moderating variable that was included as a predictor, and then we also had the interaction between the two. So I'll just type in or write in int right there for interaction, and that was our path C right there. So that's where the A and the C are coming from, and that's using the labeling that I've used previously. So if you choose to relabel using some other scheme, then you'll have to make sure that these labels that are appearing here are the same ones that appear in your AMOS file. So at any rate, following that, you'll notice that following the C, I've got a star representing multiplied by, and then inside the parenthesis, you'll see I've got a 0 minus 1.398. So the 0 is the mean on our moderator variable, and then 1.398 is the standard deviation on that variable. Now, obviously, I would not need to type in 0 minus that number. I could have just typed in minus 1.398, but I wanted to show you that that fundamentally we're using the mean minus 1 standard deviation, so that's why that's there. Then I have MEDSS. That's just basically reflecting the simple slope at a medium value on the moderator variable. So you'll see I've got A plus and then a C star, and then inside the parentheses here I've got a 0. Again, I wouldn't need to put in a 0, but if my mean for the moderator variable was not 0, then I would need to put that actual number in there. And then I've also got high SS right here, where we've got A plus C times, and then 0 plus 1.398, which again is just the mean plus our standard deviation. So that's how we can get our simple slopes for at a low, medium, and high value on our moderator. The conditional indirect effects, you'll notice I'm giving these names of low CIE, MED, CIE, and then high CIE. Those are just, again, arbitrary names. Then you'll see I've got low SS, which is coming from this right here. And so that's just basically, remember that we're taking, this is path B right here. So we're basically multiplying the simple slope for each level of W for path A and multiplying it by B. So you'll notice here I've got the simple slope at low levels of the moderator, which is, again, social value orientation, and multiplying it by B. And that gets me the conditional indirect effect at low social value orientation. Then we have medium CIE, which is just basically taking the slope at our medium level of the moderator and multiplying by B. And then high, we're just taking the high slope from up here and multiplying it by B. So that's how you can do that. And then the last part down here, I've got index of moderated mediation. And basically this is just computed by multiplying C times B, and or path C times B. And this is basically providing an omnibus test for whether or not we have evidence of moderated mediation. Other things to note too is that when you're running your analysis to test those conditional effects, we're going to use bootstrapping. So when you go under analysis properties, you'll want to go make sure that you click on bootstrap. You'll click on perform bootstrap, and I've typed in 2000 for the number of bootstrap samples. You'll notice that I've clicked percentile confidence intervals and bias corrected confidence intervals. Basically, Hayes process macro, at least the current version, is using these types of confidence intervals, but I thought I'd go ahead and just show you how to get the bias corrected as well if you wanted them. And the default in AMOS is to set the confidence intervals at 90%, but I've changed these to 95%. So here I have AMOS opened up with our model drawn in it. So again, we have our X variable here, we have our moderator variable here, and then we have the interaction term right here. Again, all of these variables are appearing in the SPSS dataset, and we had to create this by multiplying this variable against this variable right here. There's our expectations variable and our behavior variable right here. Also keep in mind that our X variable, our moderator, and the interaction between them, all of those need to be correlated. So you see the double-headed arrows on the left side of our diagram. In order to give labels to these paths, what I had to do was basically highlight a path, right-click, go to Object Properties, and then click on Parameter. Basically click on Parameters. Make sure that you actually have selected it correctly, which I just did now. You'll see down here at the bottom it says regression weight. It's got a little A in there. It's probably pretty hard to see, but there's an A here. But if I wanted to change this to something else, if I wanted to change this to Z or Q or whatever, I could easily do that. But I'm labeling this A. This one right here I've labeled as B, and then this one right here I've labeled as C. Now, you'll also then need to go under the user-defined estimands. So by default, at the bottom of the screen, you'll see it says not estimating any user-defined estimand. So what we're going to do is we are going to click on this button right here, and it says select estimands or define new estimands. So if you're creating new estimands, you're going to click on define new estimands, and then a box is going to open up, and this is basically where you can type in your syntax in order to run your model. Rather than do that, I already have my syntax already created, so I'm just actually going to open this up right here. And this is it. Just so you know, in green, these are just basically comments, and all the comments are started off with basically an apostrophe right here. So all the comment lines are showing up in green, and this is just me kind of walking you through everything that I was just telling you about. Down here, you'll see I've got my low SES equals, and then there's the A plus C times, and then inside the parenthesis 0 minus the standard deviation. That's basically the mean minus the standard deviation. Then you've got the simple slope for our A path at the mean for our moderator, and then the simple slope at the high level of the moderator. And then down here are the conditional indirect effects and so forth. Once you've typed everything in, you'll basically have to click on check syntax, and as long as it says OK, then you're ready to go. So at this point, you'll still see it says not estimating any user-defined estimand. So you do have to close the box out. And this now will change, and now it reads as estimating, are basically running the estimands. Ordinarily, if you had not saved your work, it'll force you to save your estimands in a file. So, and that's basically what I just opened up. So again, I will have that available for download underneath the video description. Next up, what we'll do is we're going to go to Analysis Properties and just take a quick look. So you'll see that under Estimation, you've got the default maximum likelihood. You'll notice that you have estimate means and intercepts. Now, if you happen to have missing data, you have to click on this button right here. The problem is that by doing this, you cannot run a bootstrap or perform bootstrapping, which is really kind of frustrating. Fortunately, our data set does not have any missing data, so I'm not going to be clicking that, and that will allow me to carry out my bootstrapping when I request it. So if I click under Bootstrap, these are the options that I had shown you before. So there's Perform Bootstrap, there's the bias corrected intervals, and just the standard percentile confidence intervals. There's the 2,000 bootstrap samples, the 95% for those intervals. So at this point, we should be ready to go. So now what we're going to do is click on Calculate Estimates, and it runs the model. So to take a look, just really quickly, we'll just look at, we'll click on this button right here. These are the unstandardized estimates. It also asks for the standardized estimates, so there they are. But basically what we'll do at this point is click our little View Text tab, and we'll click on Estimates right here. And so now you can see that we have our standard regression weights from our model. So you can see there's the X variable predicting the mediator, prime predicting expectations. You'll notice that there's a label here. That's our path A. You can see that that's statistically significant. Social value orientation predicting our mediating variable. You can see it's not statistically significant. The interaction term predicting our mediating variable, that actually is not significant. You do see the label C right here. And then you also have expectations predicting behavior. That path is significant. That's our path B. And then prime predicting behavior. That's actually that C prime I was telling you about earlier. All right, so if you double click on estimates and then go to scalars, down at the bottom you'll see it says user defined estimands. So I'm going to click on that. And when I do, you can see that these are all the estimates from our model. So for our conditional effects of prime on our mediating variable, which is expectations, that's our path A. The simple slopes at low, medium, and high levels of our moderator variable, social value orientation, these are the simple slopes right there. The conditional indirect effects that I was telling you about at low, medium, and high levels of the moderator, these are those values there. And then our index of moderated mediation is this index, this value right here. To test these, what we'll do is we'll go down to Bootstrap confidence, and now you have our confidence intervals. So just to remain consistent with Hayes' presentation with process, or like I said, the current version of it, we're just going to go to percentile method. And so you'll notice that we have all the same estimates that I was just showing you a second ago, but now we have our confidence intervals. So we have the lower and upper bounds for our 95% confidence intervals. Now the null hypothesis for all of these tests is 0. In other words, the simple slopes are 0, and the conditional indirect effects are 0, and then also the index of moderated mediation would be 0. So if 0 falls between the lower and the upper bound for any of these tests, that would be an indication that a given effect is not statistically significant. If 0 falls outside the lower and the upper bound, then that would indicate that the effect is statistically significant. So you can see that at low, medium, and high levels of our moderator variable, you can see that 0 falls outside the lower and the upper bound, indicating that we have each of those simple slopes are statistically significant. We also see for our conditional indirect effects that all three of these are statistically significant as well. Now, importantly, this variable, this index right here, index of moderated mediation, that is basically indexing the linear relationship between the indirect effect and the moderator variable. So if the test here is statistically significant, then that would indicate that we have significant moderation of the indirect effect. You'll notice, though, that 0 does not fall between, that 0 falls between the lower and the upper bound. So that is actually the death knell for our test for our moderated mediation. In other words, basically there's no evidence that we have moderated mediation present in our data. Okay, so for comparative purposes, let's just run the same analysis using Hayes process macros. So this is our data. There's our x variable, there's our moderator, there's our mediating variable, our outcome variable y, and then this is the interaction term that is formed by multiplying this variable and this variable together. So what we'll do, but we actually don't need this when we're running it through the process macro. But what we'll do is we're going to go through analyze, regression, then go down to process. We're up to 3.4 now, so I'm going to click on that. You'll see that I've got it set for model number 7, and you'll notice that we have our x variable, our y variable here, our moderator variable w right here. Since the variables are, our moderator variable is already centered, we don't really need to do anything along those lines. What we'll do is go ahead and click on OK, and it takes a couple of seconds to perform the bootstrap. We'll scroll down, and now when we're looking at our output, you'll notice that we have the conditional indirect effects of x on y. So this is at low, medium, and high levels of social value orientation, and these are basically this is one standard deviation below the mean, this is one standard deviation above, and there's the mean itself at 0. So these are the conditional indirect effects that I was telling you about. So all of these values are basically the same as what you see in the AMOS output. And then we have the 95% confidence intervals, and so in each of these cases you can see that the null of 0 does not fall between the lower and the upper bound. For the index of moderated mediation, you can see this is the same value that we get basically with AMOS, and you can see that with the confidence interval, 0 falls between the lower and the upper bound. So that's basically indicating that we have no evidence of moderated mediation in our data. So that pretty well concludes this demonstration, and I hope you found it useful. Thank you all for watching.